potential axial position potential is Kp by
R square.
R square.
Yes, sir.
Now in equatorial position, it is equal to 0.
0.
Why it is axial position means potential in the axial position means, so this is minus q plus q. Point is here somewhere, and the distance we are measuring from here
Yes, sir.
r. Okay, this is axial position.
Yes, sir.
Axial potential equatorial is minus q plus q 0. Here potential at this point.
Attracts.
Okay, no,
Yes, sir.
here potential
Yes,
q by root of r square plus l square. Here also q root of this is r.
yes, sir.
Let us take this is l.
Yes, sir.
Then this is root of r square plus
L
l
square.
square.
Yes, sir.
Okay.
Yes, sir.
So potential due to this is minus q and this is plus
Plus.
q.
Yes, sir.
So this is k into q net by r. So this term
R square plus.
minus q and plus q will become 0.
0.
So
Yes, sir.
that's why potential will become 0.
0. Yes, sir.
And at any general position, potential at any general position,
Yes, sir.
at any general position, it will be equal to 1 by 4 pi epsilon naught, that is k, into p cos theta, k, p cos theta by r square.
Yes,
Okay.
sir.
Now
Yes.
equatorial position means theta is equal to 90. If you cos 90 0, so this term will become 0.
Yes,
If you
sir.
take axial position, cos 0 is
0 is 1.
1. So Kp by
K
r
by R
square.
square. Yes, sir.
So this is axial position. This is axial position. This is equatorial position. This is any general position.
Yes, sir.
So potentials and electric fields we have discussed. Now
Yes,
we will discuss dipole in electric field.
yes, sir.
Dipole in
Electric field.
electric field is my concept.
Yes, sir.
Now you consider a electric field, uniform electric field. So dipole in electric field means electric field can be of two types. One is uniform electric field, another one is
Non-uniform
non-uniform
electric.
electric field. Now
Yes,
let us
sir.
consider a uniform electric field. So this is uniform electric field. So that means this is a positively charged plate and you are getting field lines like this.
Yes, sir.
Okay. Now consider a dipole here.
Yes, sir.
If I consider a dipole, say this is the center of the dipole, and I am having charges minus q and plus q here.
Yes, sir.
Now here the net force is equal to 0. Net force is equal to 0. See, this field
0.
lines will come like this, right? Will be like this. Field lines were moving. Now the net force is equal to 0. Why the net force is equal to 0? Because this is positive. This electric field is in
This
this
side.
direction. So this
Yes,
is QE will act in this direction.
yes, sir.
Here this minus QE, so it will attract in this direction. So QE
Yes,
in this direction. So here it is in equilibrium. sigma fx is equal to 0
0. Yes,
because
sir.
QE is acting along positive x-axis and minus QE is acting along negative
Negative
x-axis.
x-axis.
So the net force is equal to 0.
0. Yes, sir.
Okay. Now, once we have done with the net force, then we will discuss about the rotation. Okay, but here it will have torque acting on it because this is acting in this direction, this is acting in this direction, so it will produce a rotating effect.
Yes, sir.
Okay, let us take that the angle here is theta.
Theta. Yes, sir.
Okay, if the angle here is theta, then here it is theta. If this is 2L, this is 2L is the distance
Yes, sir.
from here to here, then
L.
this perpendicular distance is 2L sine theta.
Yes, sir. 12 sin theta.
Okay.
Yes, sir.
You consider it as x, then sine theta is equal to opposite side by hypotenuse. Sine theta is equal to, let us consider this side as x.
X.
Then it is x by opposite side by
Hypotenuse.
hypotenuse. Hypotenuse is 2L.
2L.
So x is
X.
equal to 2L
2L sin theta.
sine theta. That's how I got x is 2L
Sin theta. Yes,
12
sir.
sine theta. So
Yes, sir.
now this is translational equilibrium. This is in
Translational equilibrium.
translational equilibrium.
Yes, sir.
So the net force acting on it is equal to 0. But
0.
rotational equilibrium it is not having. It is rotating. It means
Yes,
torque is acting on the body.
yes, sir.
Okay. So that torque we write the torque as we write the torque as and now torque acting on the body, torque is equal to uh, R cross F. R is perpendicular distance into force. Force into perpendicular distance is torque.
Yes,
Force
sir.
is QE,
QE.
QE, and R cross F, right? So first I will write R, and then I will write F. Okay.
Yes, sir.
So R is 2L, perpendicular distance
2L
is
sin
12
theta. Sin
sine
theta.
theta into F. F is
What
here I
is
will write
E?
torque is equal to R cross F. In this formula, I am substituting in this formula. Torque is
Yes, sir.
equal to R cross
R
F.
cross
2L sine theta into F. F is nothing but QE.
QE. Yes, sir.
So from this, I will write Q into 2L sine theta
Yes, sir.
into E.
Into E.
But
Yes.
this is Q into 2L is P.
P. Dipole.
So
Yes,
this
sir.
is
PE sin
electric
theta.
dipole moment.
Yes,
So
sir.
P sine
Sin theta.
theta. So we can write P cross
P
E.
cross E. Yes, sir.
Torque is equal to
P cross E.
P bar cross E bar. Okay.
Yes, sir.
That is equal to P sine theta.
Yes, sir.
This is dipole in uniform electric field.
Yes, sir.
This is uniform
Electric field.
electric field. Okay.
Yes, sir.
Torque is equal to P cross E. Now, non-uniform electric field. Now I will apply non-uniform electric field and see what happens.
Yes, sir.
Non-uniform, right?
Yes, sir.
Non-uniform
Electric.
electric field. In non-uniform electric field, see these lines, electric field lines, are like this.
Yes, sir.
Why? Because this is non-uniform. Nah?
Yes, sir.
Now here, if you place a dipole like this, okay, now this is minus q and
Plus,
this is
plus
plus
Q.
q.
Yes, sir.
Now here this force q into E, here electric field is more, here electric field is less, because here
It,
field lines are closer, so the electric
it
field is
more.
more. Here field lines will be farther, so electric field is
Less.
less. So
Yes, sir.
here you will have both translational and rotational.
Rotational.
So
Yes, sir.
here if you will have F is equal to Q into, at this position is A. Electric field at this position is A. At
Yes,
this
sir.
position electric field is
B.
B. Then
Yes. QEB. Yes,
so
sir.
you will have force, you will have net force, and obviously you will have torque.
Yes, sir. P cross E.
Okay, here sigma F won't be equal to 0.
0. Yes, sir.
Okay,
Yes, sir.
right. Then next point is work done in rotating a dipole in uniform electric field.
Yes, sir.
Work done in
Rotating a dipole.
rotating a dipole in
Uniform electric.
uniform electric field.
Yes, sir.
Work done in rotating a dipole in uniform
Electric field.
electric field.
Yes, sir.
Now I'll consider a uniform electric field. Okay, the
Yes, sir.
straight lines equidistant denotes uniform electric field. So
Yes,
this
sir.
is uniform electric field. In this uniform electric field, I will change the angle. Say initially the dipole is like this.
Yes, sir.
Should I use another color? Okay. This is minus q and
Yes,
this is
plus Q.
plus q.
Yes, sir.
Now let us take the angle with the field is theta
T.
1.
Yes, sir.
Okay. Now, okay.
Yes,
Now this will be pushing in this direction, right?
yes, sir.
Okay. This will be pulled in this direction. So this is trying to rotate in this direction.
Yes, sir.
Okay. Like clockwise. Now this is
Clockwise.
trying to move clockwise
Anti.
because
Yes,
uh,
sir.
clockwise,
Yes, sir.
right?
Yes, sir.
Clock it will move like this only, na?
Yes, sir.
So now this is trying to move in this direction. This is trying to move in this direction. So it will try to move in this direction. Okay. But okay. So
Yes, sir.
against this, you move in anti-clockwise direction. You push it from here to here.
Yes, sir.
So if you push it from here to here,
Yes, sir.
okay, let's draw. This is also in the field.
Yes, sir.
Okay, now the angle here is now theta 2.
2. Yes,
So
sir.
theta from theta 1 to theta 2 against the field
Yes, sir.
you have moved. Okay, then the work done by you is equal to PE cos theta 1
Yes, sir.
minus
Cos
cos
theta
theta 2.
2. Yes, sir.
E into cos theta 1 minus
Cos
cos
theta
theta 2.
theta. Yes, sir.
Okay. So this is the formula. Work done is equal to PE into cos theta 1 minus cos
Theta
theta 2.
2. Yes,
Now
sir.
initially if it is along the electric field, then theta 1 is equal to 0. Usually.
0. Yes,
If
sir.
theta 1 is equal to 0, theta 1 is equal to 0 means initially it is along the field. Now you change
Around
it to an angle theta. That
theta.
means
Yes, sir.
theta 2 is equal to theta. Then work done is equal to
PE cos
PE
theta.
into cos 0
Cos
is
cos 0 1.
1. So PE into 1
1 minus
minus
cos theta.
cos theta. If you are turning from the stable position
Yes, sir.
to an angle theta, then work done is equal to PE is equal to work done W is equal to PE into 1
1 minus
minus 1 minus
cos theta.
cos theta.
Yes, sir.
Okay.
Yes, sir.
So this is work done in rotating a dipole in uniform electric field. Work
Yes.
done. What is the formula? PE into,
Cos 1 minus cos theta.
yeah, if that is theta 1 is equal to 0,
Is
then
equal to
only.
0. Yes, sir.
Or else
P into cos
from
theta 1 minus cos theta 2.
initially from theta 1 to theta 2 if it is moving, then PE cos theta 1 minus cos theta
Cos
2.
theta 2. Yes, sir.
Yeah. Okay.
Yes, sir.
Right.
సో 2021 క్వశ్చన్ డైపోల్ మూమెంట్ అది ఒకసారి ఎక్స్ప్లెయిన్ చేయండి.
2021.
ఎస్ సార్.
Okay.